Okay, so seeing how we can generate all these terms in a sequence, now we want to come up with a specific way to come up with a formula that we can use to figure out any terms in the sequence. So here I'm going to use example number 2 to show you how we can use terms in the sequence to generate a formula. And that formula will then be the equation for you to figure out any terms in your sequence. Or we call that formula the general term of a sequence. So here in example number 2, state the first 4 terms on an arithmetic sequence starting with 50. That's term number 1. The little subscript is to indicate the number of terms that you are dealing with. Here we have -9 for the pattern. The numbers are going down by 9. So the second term in this case would then be down by 9. So that would be 41. Term number 3 in the sequence would then be 32. And then 23. So how do we come up with a formula for all these terms after 23? Now let me go back to term 1 and term 2 and term 3 and term 4. Instead of getting 41 here, if I can express this as 50 plus -9, as I said, when we are talking about a arithmetic sequence, I want to consider adding a positive term or adding a negative term. In this case, I am adding -9 to term number 1. And then as I move on to term number 3, starting from the first term again, starting from the beginning, I will be adding -9 2 times. And then for term number 3, I'm adding -9 3 times. If I want to get term number 5, I will be adding the first term by -9 for how many times? If I have T5 here, I'm starting from 50, and I will add this -9 by how many times? 4 times. So as you can see here, we are starting to see a pattern. You will be starting with 50 for sure. You're always starting from term number 1, and you are doing this pattern for that many times. So if I want to come up with a formula for Tn, I will still be starting from 50, and I will be adding this pattern for how many times? X times? Well, what does it mean by your x? What does it mean by x minus 1? The term minus 1. If you were looking for term 4, you times it by 3. If you were looking for term 5, you times it by 4. If you're looking for term 3, you times it by 2. Every time it goes down by 1. So if I want to find the nth term, this will then be 1 less than what you're trying to find. So altogether, you can simplify this to 50 plus -9n plus 9, or altogether 59 minus 9n. And this will be the formula to figure out your general term. It works pretty similar to y equals mx plus b. Y equals mx plus b. When you were drawing your straight line, you start your line from the y-intercept and the number continue to go up based on the slope given to us. This time we are starting from 59 at the beginning. Well, not quite at the beginning because we are having 50. Because when n equals 1, 59 minus 9 would then give us the first term. And then the second term and the third term and so on by changing the value of your n. So based on what we see, we can now come up with a formula for any arithmetic sequence that started with a given first term, which we call term number 1, and you keep adding the same number again and again for this many times. When we are to find the equation for any term of an arithmetic sequence, we can always use this formula. Starting from term 1, this is term number 1, you keep adding the same pattern again and again. And you will be able to find the equation for your general term. So when you're working on the arithmetic sequence, it will be the best if you can identify the first term and the common difference right at the beginning. If you can identify the pattern first, you will be able to find the rest of the terms in your arithmetic sequence. If you don't have the common difference given to you, you want to find it first.